Sketch the graph of y equals negative x to the power of 4 plus 9x squared on the set of axes provided. Clearly label any axial intercepts with their coordinates. So the first thing we can do is we can inspect the equation of the chordic that we wish to graph, and we can see that negative x squared is a highest common factor that can be removed. Therefore, we can write this equation as y equals negative x squared times x squared minus 9. We can recognise that this is a DOPS, a difference of two squares or a difference of perfect squares. And that means we can further factorise this to be y equals negative x squared, x plus 3 and x minus 3. So that's the fully factorised form for this chordic equation. The next thing we can do is find the x and y intercepts of this graph. And if we have a look, this factor of x squared means that we're going to have an x and y intercept at 0, 0. So we're just going to find the x intercepts of this graph, and that occurs when y is equal to 0. Therefore, 0 is equal to negative x squared times x plus 3 times x minus 3. Using the null factor law, we can say that x equals 0, x plus 3 could equal 0, or x minus 3 could equal 0. If we subtract 3 from both sides of this equation, we find that x is equal to negative 3, and if we add 3 to both sides of this equation, we find that x is equal to positive 3. Therefore, we have x-intercepts of negative 3, 0, 0, 0, and 3, 0 if we order them from negative to positive. Now that we've found the x-intercepts and the 0, 0 doubles up as the y-intercept, we can now start to think about the shape of this chordic. So the negative sign out the front of the x to the power of 4 term means that the chordic should have some sort of shape like this. So when we have x equals negative 3, it should have a cut through the x-axis. At x equals 0, we should expect a local minimum turning point. And then at x equals 3, we should expect another cut going through the x-axis. So drawing that on, we have this shape here as our graph. The key features were an x-intercept at minus 3, 0, an x-intercept at 0, 0, and an x-intercept at 3, 0. Over on this slide, we've used a computer to graph the same chordic graph. And you can see that all of the key features are in the same locations, and we've also got the computer to put the coordinates on for the local maximums.